Welcome to F5's Distributed Cloud Platform for Service Providers. In this demo, we will demonstrate how the F5 Distributed Cloud Platform can power service providers move to a cloud-native architecture. This demo will show a 5G core running in one instance of F5 Distributed Cloud AppStack, and a second instance of AppStack running the UPF, all orchestrated, managed, and monitored through F5 Distributed Cloud Console. First, we will look at the topology of the demo. As you can see from the diagram, we'll be using free 5GC, which is an open source implementation of a 5G core. The 5G core will be running on one AppStack cluster. The second AppStack cluster will host the UPF. We'll be using a 5G UE simulator that will simulate connections and traffic during the demo. The UE will first connect to the AMF service of the 5G core. The AMF will communicate to the other 5G services within the AppStack cluster. Next, the SMF will communicate to the UPF to initiate connection from the UE to the data network, providing access to the internet via the N6 interface. Let's take a look at the Distributed Cloud Console. You can see each AppStack cluster running. The first one is labeled the SBA 5G core, which is hosting the free 5GC open source 5G core. The AppStack labeled 5G Edge is where the UPF is running. We will be using a Linux desktop to simulate a 5G mobile phone. The simulated phone will start offline. The different CNFs that make up the 5G core will be deployed along with the UPF. To connect the simulated phone, we need to first add a new subscriber to the network via the 5GC UI. Next, we will simulate the initial connection and subscriber validation of the mobile device to the network. As you can see, we can now access the internet from the simulated mobile phone. F5 Distributed Cloud simplifies the operation, networking, and security of multiple Kubernetes clusters and the network functions and services running in those clusters. We can examine the different services and communication links within a cluster via the Cloud Console. The services graph is discovered by AppStack, and you can see the different services that comprise the 5G core. You can also observe and visualize the overall health, metrics, message rate, and services. You can even visualize the traffic flows between the services. If there are issues detected, then those will be visually flagged in the graph. Message request information can also be obtained through the console UI. The API Endpoint tool provides a graph view of all the endpoint APIs for the services running in the cluster. These endpoint APIs are discovered by AppStack. Behavioral analysis on various logs collected is performed using advanced machine learning. This analysis provides visibility into the health and trend information of all the APIs. This is helpful to identify which APIs are getting hit the most and associated message size. This can be very beneficial in providing visibility into potential bottlenecks. From the console, additional insights for all the services can be viewed, including flagging unhealthy services, error rates, latency information, and request rates. Thank you for your time.